everyone, welcome to another session of Python. Today we are going to discuss insertion sort. The name itself makes everything clear. Insertion of an element in a sorted list. What does that mean? Yes, of course, definitely I'll be telling you. Do you remember how you arranged handful of cards while playing card game? Yeah, you picked one card and tried to insert them in a proper position because you always prefer them to be in a sorted manner for easier accessibility, right? Similarly, you might have observed how tailors arrange the shirts in a cupboard. They always keep them in a sorted order of size. Thus, to insert a new shirt at the right position, what he does? He compares the sizes, right? Moves the shirts backwards, and finally he inserts or keeps this shirt to its exact position, right? So in both the examples, what did we observe? Yes, we were inserting an element from an unsorted part into the sorted part. So the algorithm of insertion sort simply defines like when you are going to insert the element, you begin from left to right. So if this is an unsorted array, you have to take the first element from left. But I assume that the first element is already sorted, fine. So we have to work from index number 1 towards the end of the array, right? So examine each element. So in this case, I am beginning from 9. Examine each element and compare it to the items on its left. So 9 is going to be compared with the item on its left, that is 15. Okay, so I'm 15 and 9 are compared. 15 is bigger, so I'm shifting it and finally placing. Because no more elements are there to be compared, so I'm going to place this 9 to its exact location. Cool. Now insert the item in the correct position in the array. Cool. Okay, so you might be observing here the array will form sorted and an unsorted partition. So the green color which I have shaded over here shows the sorted partition, whereas the rest of the elements are remaining in the unsorted partition. Now let's follow these steps and see what happens if I'm going to repeat this algorithm to each and every element in the array. Okay, so again let me repeat. 9 is considered, the second element is considered, compare with all the elements to the left. Here I have only one single element, so it's compared with 15. Since 15 is bigger, shift it and insert the 9 to its exact location. Cool. Now take another element from the unsorted part. Okay, the second element is in index number 2. 8 is compared with 15 and 9. Okay, so when I compare 8 and 15, 15 is bigger, shift it. Then comes the 9, 9 and 8, 9 is greater, so shift it. And then insert the 8 exactly to its right position. Now we will be moving ahead towards the right. So take the next element, that is 10. 10 is going to be compared with each and every element. So here if I compare 10 and 15, 15 is bigger, so shift it. Then comes 9, 9 and 10. 9 is not greater than 10, so no more shifting. The rest of the elements will remain there. I have to come back here and 10 should be inserted into this location. Cool. So moving ahead, last number 7. 7 is compared with 15. 15 is greater, shift. 10 is also greater, so shift. Next comes 9. 9 is also greater, so shift it. 8. 8 is also greater than 7, so shift it. No more elements are there to compare, so we are going to insert this 7 to its exact location. Cool. So now you can see the entire array is sorted. I hope the algorithm is made clear. Okay, so it's time for practice. Let's solve this question. Okay, so given an array and we have to sort it in ascending order and you have to show all the passes of insertion sort. I have written all the elements. Okay, each pass. So first pass is like we will be taking this element and compare with the left side. Compare it with the sorted part, right? So first pass is this one, 79 compared with 95. Do we shift? Yes, we have to shift 95. 79 is inserted there. Now take down all the elements. Fine. What is the next element? 19 is compared with 95. Shift it. 79. Shift it. Then 19 is inserted. Cool. Next, take down the rest of the elements. Next is your 43 is compared with 95. Greater. So shift. 79. It's greater. Shift. 19. Okay, 19 is less than 43. So no more shifting. 19 is placed as it is. Come back over here and insert 43 to its location. Now let me compare 52 with the rest of the element. 95 greater, 79 is greater, so shift. 43 is not greater. So no more shifting. So these elements are kept as it is. Now come back over here in this position, fine, and insert 53. Cool. So that brings us to the end of this session. Hope you followed the algorithm. Meet you soon with the next video to dive into the coding part of the algorithm. Till then, happy coding!